So once again, we were talking about how we want to keep our angle as simple as possible. We don't want to work with angles that are too big. We want to simplify our angles. We want to keep these angles small enough so that it is easy to work with. And therefore, we use something called the reference angles. Reference angle will always happen between the terminal arm and the x-axis. Sometimes it could be the positive x-axis. Sometimes it could be the negative x-axis. So when you are talking about angles that go all the way to 355 degrees, a very big angle, you don't want to deal with 355. You want to simplify it. Yeah, that would simply be 5 degrees away from 360. Instead of measuring your angle going from 0 degree and turn almost a complete circle to get 355, this angle goes all the way to quadrant number 4. You may want to describe this angle as a 5 degree angle in quadrant number 4. And usually we will have this angle indicated with R. Or some people actually will have reference angle. Using the same concept, if I have angle that is this big, 260 degrees, this angle will definitely go beyond 90. It will go beyond 180 for sure. It will stop right before 270. This is 270 degrees, but your angle here is now 260. This angle will have a reference angle of 80 degrees. 260 minus 180. This angle is bigger than 180, but we are trying to compare this angle with the x-axis. And here you see 180 there. So that would give us a reference angle of 80 degrees.
So reference angle, you subtract it, and then on the other one, the reflect angle, add it?
It depends where you are at. Sometimes you will subtract your angle by 180. Sometimes you will have 180 subtract your angle. And if it is in the fourth quadrant, you will have 360 degrees minus your angle.
So you don't have to say which quadrant it's in, you just put...
Well, we simply say the reference angle. Yeah. We will deal with the quadrant at a later time. Yeah, we will combine that idea with reference angle and try to solve your triangle using these concepts. But we definitely wouldn't call this 10 degrees. You are not using your y-axis to describe your angle. We will not use this angle. Physics, probably, but not in pCal. We will use the angle between the terminal arm and the x-axis.